you. I know you said it, but
Monday. Okay, so hopefully I can actually have this thing working. That would be wonderful. Unplug that. And of course, have to reboot. Emma, could you close the door, please? Alright, let's see here. Okay, so today we are going to be proving lines are parallel. So we're going to do line proofs. Part 1. Okay, so you're going to have a bunch of theorems. Okay, so I'm going to reword these so that we can actually use these same notes for the next section, which is very similar. It's just going the other way. We're going to start with the phrase, lines are parallel if and only if. So it goes both ways. Lines are parallel if and only if the alternate interior angles are congruent. So, if I have the lines parallel, I say the alternate interior angles are congruent. If I have alternate interior angles are congruent, I say the lines are parallel. So in practice, this is what this is going to mean. Here are my lines. If they're parallel, and this angle here is 50, what is x? 50. Those are alternate interior angles. Don't fixate on one orientation. We could have multiple orientations. So here's another transversal. Let's get some algebra into the mix. So let's say that this is x plus 5, and let's say this is 120. What do we know about these two angles?
they're equal.
So I'd say x plus 5 equals 120, but this is only if these two lines are parallel. So I'd say like line L and line M, I would say L is parallel to M. Notice that symbol parallel. So I could solve this and say x is 115. Any questions on that? Okay, so lines are parallel if and only if the alternate interior angles are congruent. Now, of course, we'd have to have a transversal in the mix as well. So here's my transversal T. Okay, we're going to start with the same phrase. Lines are parallel if and only if the corresponding angles are equal. All right, I should say this first one. I would say alternate interior. Oh, my gizmo is not working. Angle theorem. That's what that's called. And this one will be the corresponding angle theorem. So you could write out the whole thing in a proof, or you could write the name. All right, let's do one with the corresponding angles. So given that these lines are parallel, so L is parallel to M. If this is 100 and this is x, what's x? 100. If these lines are actually parallel. Make sense? Corresponding angles are congruent.
So that means that the other side, like the alternate alternative away from x, is also 100 to be sure that they're parallel.
So this one would be 100 as well?
Yeah.
Yes. And there's lots of ways that we can get there, and it's good that you see the lots of ways. Those two angles are vertical. These two angles are alternate interior. So there's several ways to get the same answer. All right, so let's say I have L is parallel to M again, and let's say this is x plus 5, and let's say this is 2x minus 10. So if these two lines are parallel, what do I know about x plus 5 and 2x minus 10? Okay, so I can subtract the 2x and get negative x. I can subtract the 5, get negative 15, and x is 15. Solve it. So then what is the angle? Well, I substitute in and get 20. Okay? Not drawn to scale, but that's what we get. Okay. Like that. We get the next one. Any questions so far? Don't do that one. We'll definitely do that one. Okay. Next one. This is the same side interior theorem. Lines are parallel if and only if the same side interior angles are supplementary. So here's a picture of that.
I'm sorry, what was the abbreviation beside angles mean?
Same side interior. Same side interior. Lines are parallel if and only if the same side interior angles are supplementary. So here's my two lines. I have my transversal. And let's say this is 30 degrees and this is x. Those are same side interior angles. So what equation could I write? Given that L and M are parallel.
X plus 30 equals 180.
Thank you. They are supplementary, which means these two angles add up to 180. Let's say I have a y in the mix. Y plus 20 and y plus 50. What do I know about those two?
They equal each other.
They do not equal each other. They are same side interior. What does my theorem say?
They're supplementary.
They're supplementary. So what do I do with them?
They equal 180.
I add them and get
180.
180. You need to not assume in every problem that the angles are equal. In fact, just look at it. Do those angles look equal? That's obtuse and that's obtuse. They're not possibly equal.
So
Yes.
but y plus 20 equals 30. Because they're,
These would be alternate interior, and yes, those would be.
and so that's why x plus 30 equals 180. Because x,
These are same side interior, and it's by our theorem.
Oh, so the only way that we know that the angles that are on the same side interior are 180 is because of the theorem, not because usually when
Yeah, because that does not look like it equals 180.
yeah.
Okay, let's look carefully.
Okay.
Oh, with the two 90-degree angles, is that why it's 180?
No,
Oh, wait,
look,
never mind.
look carefully. Let's do a quick proof. Let's use alternate interior angles. Let's say this one's 20 degrees, and let's say that these lines are parallel. So L is parallel to M. These two are
Equal.
because
They're
alternate interior. Okay. These two are what type?
supplementary.
Because they are a linear pair, which means this is 160. These are same side interior. Same side interior angles are
180.
supplementary. They're 180. So actually we could take out the word theorem. This should be different things. But same side interior. We add these. So let's go back to the y's. These are same side interior. So 2y plus 70 equals 180. Subtract the 70.
Oh, okay. I got it.
Divide by 2. And we get 55.
Oh, and it equals 180 because doing the y plus whatever that is plus 30, that would be exactly the same as doing x plus 30 equals 180 because they're across from each other, so they're equal.
Right.
Yeah. And I actually set this up as a different problem, so I would like this ignore the x's in this case. Because I've set up a different question. Alright. So, questions on the same side interior. Okay. Lines are parallel if and only if the alternate exterior angles are congruent. Okay, so by this diagram, this angle and this angle would have their alternate exteriors, so they are congruent.
So still equals 130.
Yes. Subtract the 12 and get x is 88.
Is it the alternate exterior here?
Yep. Okay. Now let's practice this. So here's my diagram. We have a pair of parallel lines. So I'll have line L, line M. We'll say line L is parallel to M and transversal T. And let's say this angle down here, let's say this is 50 degrees. Let's find all the other angles and justify. So, what's angle 6?
50.
Reason.
Vertical
This
angles.
is vertical.
Okay, vertical angles. You would use that in a proof. Statement, reason. Okay, so this is 50. All right, using this 50, so we're using that 50 right there. Get me another angle.
Angle
2
7
is 50.
130.
Angle 7 is 130. Reason.
Because it's supplementary.
Supplementary.
So is angle 5.
Yeah.
Even though
Okay.
it's like
So angle 5 for the same reason.
And then number 2 is 50 for
that.
the
Then
alternate
angle 4 is
exterior.
130.
Okay, hold on. We have angle 2. Daniel is what?
50 because alternate exterior is here.
Alternate exterior angles, okay? And so this is 50. Let's get down all the ones we know.
Angle 1 is 130.
Yeah.
And
Hold on. You're going as fast as it came. All right, so angle 1 is what?
130 because supplementary.
Okay, well, before we get there, let's get angle 3. What's angle 3?
Angle
50.
3 would be 50.
Reason.
Interior.
Alternate interior.
Alternate interior. Sorry.
Okay, so it's alternate interior to 6. Can we get it from this one?
From 50.
Yeah, but I don't know how you.
Same.
Corresponding.
Corresponding.
Okay, now we can get angle 4. Angle 4 is not 50.
it's 130.
It's 130. Now I can't get it directly from this one, but I can get it from these
Or from the 5.
or from the 5 alternate interior. So 4 is alternate interior to 5 or same side interior to the 50, angle 6.
Supplementary.
Well, the reason we would give for 4 and 6 here would be same side interior
Could also be corresponding to 7.
and corresponding to 7. So lots of different things there. Angle 1, we could say corresponds to angle 5. So that gets us our 130. So you see how you do this?
It's a lot of difference.
Okay. Let's do another one.
So Kane, which one do we need to put? Do we need to put the definition of alternate interior or should we put the theorems in there?
You would write the word theorem.
Theorem.
You want, it's not a definition.
Oh, it's not. It's you just repeated them. And just
Yeah, it's a
if and
theorem.
only if.
Yeah. Okay. In the proofs you wouldn't say definition for these. They're theorems. All right. Let's say this is. Well, I already did that one. let's say this one
Can you
is
do a different
45
angle?
degrees. I am doing it.
Like flip it sideways.
Yeah.
Because those.
Okay, we'll get that. Get X, Y, Z, and W. Go ahead and do it on your own. Get X, Y, Z, and W. And give me a reason for each one.
Well, you never told us that the lines are parallel, so technically we can't get anything.
Okay, fine. L is parallel to M. Good catch there. Yeah, you do have to know that the lines are parallel first.
What is that little squiggle on the side?
It's called I'm a squiggle.
I am a squiggle. You might want to put a patent on that before Apple steals it. I am a squiggle.
I squiggle.
I squiggle.
What if we know how to get it, we just don't know the term for it? Like, I know that to get X, we do 180 minus 45, but I don't
These
know.
are same side interior.
Oh, never mind me. I'm
Mr. Kane.
I'd be so lost on this.
Do you want us to only use the theorems, or can we use like supplementary?
You can use supplement here. Okay, check your answers. I did all of mine with respect to this angle. So Z is 45 because it's vertical to the given angle. W is 135 because it's a supplement or a linear pair with the given angle. Y is 45 because it's alternate interior to the given angle. And X is 135 because it's same side interior to the given angle. Now you could do different methods, like if I found W is 135, I could say W is an alternate interior angle to X.
And that wouldn't be wrong if we did
And that would not be wrong, but you need to specify.
Yes, sir.
Okay, I have another diagram here sideways. Go ahead and do the same thing.
Supplementary.
What's that, 62?
Yep.
Hold up. Oh man, I would not.
Oh, it's just like Can on our test, would we be allowed to like rewrite it to the side? I know it sounds funny, but like for
I suppose.
Please give us more room.
Show all work on the test and no, you're not getting any more room.
Why what if we don't show work on the test?
60?
62.
That's a 62.
Okay, sorry. I don't have my glasses on.
All right, X, call it out. What does it equal?
62.
118.
No,
118.
Because
Okay,
same
then.
side interior.
Oh.
They are, no, they are not same side interior.
You gotta do the alternate exterior for W, and then you can supplement it.
Yes. Okay, so Daniel has listen. We have to get W first. What is W?
W is 62
And reason is
because it's alternate exterior. thing.
alternate exterior. Now, because we have W is 62,
Supplement.
we could say X is supplementary to W. All right, what's Y?
Y is also 118.
Y is 118, and we say supplement to the given angle, 62. How about Z?
Z is gonna equal 62 also because vertical.
Because it's vertical. Now, if we got Z first, we could say this is 62 and W is 62 because it's corresponding. So there's a few different ways that you can get this. All right, let's try this diagram.
Like food pyramid.
Okay. Now let's think. This is a triangle here, which really isn't that important because I am concerned about the parallel lines. So if I just highlight this a little bit,
Wouldn't it be the same,
these are
SSI?
same side interior.
Yeah.
So they're supplementary. So I'd say x plus 18 plus 100 is 180. X plus 118 is 180, and subtract the 118 and get 62. Okay, I'll give you a moment to copy that, and then we'll do another one. The original drawing was this.
Is this an equilateral triangle? Does that really matter? But
It is not necessarily. There's no information. You okay, Plant and Justin?
No, not my elbow. He hit his elbow.
Okay, I'm sorry. Pay attention.
It's nice to know.
God bless you.
Does your triangle have to be slanted? Yours are always slanted.
You don't, I didn't make my play.
Okay, I'm about to go on, so
Yeah, you're good.
I catch these on YouTube.
look carefully up here at what I'm about to do. When you have arrows pointed in the same direction of lines like I just did, this means the lines are parallel. You with me? Do you see what I did to those lines? If I put a hash mark here, I mean not only are they parallel, but the segments are congruent. Okay, yes. So, these lines are parallel. So if those lines are parallel, that makes this a transversal. You with me? So sometimes you have to complete the diagram a little bit to see these lines are parallel. That means these are same side interior, which means I can do what?
You can add them up to 180.
Yes,
Because they're supplemental.
because they are supplementary. Same side interior angles are supplementary.
Yay.
Okay? We good?
Mm-hmm.
Get that down?
Okay. You talk to me.
Last diagram, and then we'll do some practice. And you won't need your notes. Given that L and M are parallel in this diagram, what type of angles would these be? And therefore they are? So 60 minus 2x equals 2x plus 60. Now what do we do?
Add 2x and 4x and subtract 64 equals 0. What? X equals 0.
So this is 60 degrees and this is 60 degrees. Okay, wrap up your notes. And turn in your books to page number 153.